All right, so let's talk about two different topics, arc length and the area of a sector. So first, let's think about arc length. So here's what arc length is, okay? Arc length is just the length of the arc, S, like I mentioned before, we use S for arc length, subtended, I mean kind of like sketched out, by an angle with measure theta in radians, okay? So you can remember this. I don't usually remember this. I'll show you when I have problems like this how I just use a ratio that I can remember in my head, easier than this. But if this makes sense to you, awesome. The arc length is the radius times the angle in radians. Okay, it has to be in radians, doesn't work if it's in degrees. Okay, so S equals R times theta. Let's do an example, a problem where we might need to do this. All right, so they tell us, and this is actually kind of interesting. Assume the orbit of Mercury around the sun is a perfect circle. Okay, so we've got our circle. All right, so there's our orbit of Mercury. We know that they're not actually circles, right? They're like ellipses or something, but we're going to pretend it's a perfect circle. Mercury is approximately 36 million miles from the sun. So the radius is 36 million miles. In one Earth day, Mercury completes 0.0114 of its total revolution. How many miles does it travel in one day? Okay. So it's telling us it completes 0.0114 of its total revolution. What is its total revolution? Its total revolution is 2 pi, right? So it's completing 0.0114. That's what its angle is. This angle is 2 pi times that amount. So how many miles does it travel in one day? So we can do it two ways. I'll show you the way that I think about it, and then we can just use the equation they gave us. Either way works. So I like to think, how many miles does it travel in one day? Okay, well, the ratio of its arc length, S, right? That's really what it's asking us, right? How many miles is this? What's the arc length? That's how much it travels, right, along that circle. So the arc length, the ratio of that arc length to the whole thing, what's the whole thing? 2 pi times the radius, which is 36 million miles, right? The circumference of a circle is 2 pi r, equals this angle, 2 pi times 0.0114, divided by the whole thing, which is 2 pi. Right? Okay, can we simplify this at all? Yeah, we can. These 2 pi's cancel. We can say S equals 0.0114 times 2 pi times 36 million. And we can put that in our calculators. And I'm going to cheat because I think they already did that for us. Which is 2.58 million miles. Or we could write 258,000 miles. Right? So the key is this ratio, right? Knowing the arc length to the circumference equals this angle to, so let's write that, arc length to the circumference equals the angle that it travels divided by 2 pi. This ratio is all I remember to be able to solve these problems. If we wanted to just use this instead, S times R theta, right, the thing that they gave us, S equals R times theta, we could do that, right? S would be, let's see, the radius is 36 million. And the theta we figured out was 0.0114 times 2 pi. Gives us the same thing. Whoops, I can't see that. Totally the same answer. Either way is fine, whichever makes more sense to you. If you like this ratio, I just like the ratio because it makes sense to me and it's one less equation to memorize. I'm not good at memorizing equations, but I'm good at memorizing concepts, right? And this makes sense to me. The arc length, the ratio of the arc length to the circumference is the same as the ratio of the angle to 2 pi, okay? All right, let's look at the second part. They say use your answer from part A to determine the radian measure for Mercury's movement in 1 Earth day. Okay, what's the radian measure? So radians, and this is the definition that we should know. Radian equals arc length divided by radius. That's the definition of a radian. It's the arc length divided by the radius. So the arc length, well, we kind of figured that out, was 36 million times 0.0114 times 2 pi divided by the radius, we know is 36 million. So these are going to cancel out. The radian measure is that. Okay? All right. So 2 ways you can do this. If you need to find arc length, S equals R times theta. I mean, it's not like that's a hard equation, right? You could do it. You can memorize that. Or you can use ratios. Okay? All right. So now let's talk about the other thing, the area of a sector, which I feel like is a similar concept. The area of a sector of a circle with radius r subtended by an angle theta measured in radians is, and they give us this equation, 1/2 theta r squared. You can totally use this equation. This doesn't even look familiar to me because I, again, just use a ratio. All right, so let's look at the problem they give us for this. We've got an automatic lawn sprinkler that sprays a distance of 20 feet. That distance is 20 feet while rotating 30 degrees. What is the area of the sector of grass the sprinkler waters? Okay, so radius is 20, angle is 30 degrees. All right, first let's do it the way that I think about it. Okay, I'm going to use a ratio. So the area of the sector divided by the whole area of the circle equals the ratio of the angle that they give us to 2 pi, or 360 degrees. In this case, they give us it in degrees, right? That ratio, the ratio of this area to the area of the whole circle is going to be the same ratio of this angle to the angle all the way around. So let's just call our area A. What's the area of the circle? Remember this? It's pi r squared. So they tell us our radius is 20 feet. So it's going to be pi times 20 feet squared equals our angle, 30 degrees, divided by 360 degrees. Cool. So what do we get? We get that our area is 30 times pi times 400 feet squared divided by 360 degrees. Our degrees cancel. This cancels with this to be 12. Does 12 go into that? No. 4 goes into that 100. 4 goes into that 3 times. So let's say 100 pi divided by 3 feet squared. We can keep it in exact form. We could put it in our calculator. Either way is fine. To me, this ratio makes a lot more sense than memorizing this. Okay, however, some people like equations, we can use that. We could say, okay, let's do it this way instead. The area is 1/2 times theta, but remember, theta has to be in radians, so they are trying to trick you in this problem. 30 degrees, let's see, 30 degrees, how can I convert that to radians? It's going to be pi divided by 180, right? It's going to be pi 6 radians. Okay, so times pi 6 times the radius squared. So again, I mean, we'll get the same answer. Pi times 400 divided by 12. And that's feet squared, which if we simplify is the same thing, which we'd expect, right? Either way is fine. I prefer this ratio. If you prefer the equation, go for it. They're both awesome ways to calculate area. All right.